3, 4, 5, 6. So will it come? No. Yeah, maybe. Yes. Good, 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 good. Now, no. Where it can be? Oh my God. Yes. Yeah, obviously it will be here. And the remaining it will go. Yeah. Success. Good. Dear children, do you know what I did now? Yeah, it's a beautiful jigsaw puzzle. So dear kids, our earth is like a huge jigsaw puzzle, just I did now. So where the individual pieces are fitted together to create a big picture. However, the landforms that we see on the earth's surface have not remained same as forever. Rather, they are changing. So our earth has not always looked the same. About 250 million years ago, all the continents were joined together as a supercontinent known as, do you know what is? Yes, Pangaea, set in a huge ocean called Panthalassa. Remember, the continents were joined together into a supercontinent known as Pangaea and oceans called Panthalassa. Clear? According to the theory of the continental drift by Alfred Wegener, the supercontinent Pangaea began to break up about 200 to 225 million years ago. So the theory says that initially two massive continents, that is Laurasia and Gondwanaland, were formed. Laurasia and Gondwanaland were formed, eventually fragmenting further to form today's continents. So, dear kids, now we are going to learn about the lithospheric plates. The Earth's crust is broken up into a series of plates called lithospheric plates. Very important. What do you mean by lithospheric plates? What is lithospheric plates? Earth's crust is broken up into a series of plates. So that is known as lithospheric plates. There are 7 major lithospheric plates and some minor ones. Okay, how many are there? 7 major. The 7 major lithospheric plates are here. The first one is the South American plate. The second is the Pacific plate. Then the African plate. Then the Indo-Australian plate. Then the North American plate. Then the Antarctic plate, and the last is the Eurasian plate. Remember, so here also we can use a mnemonic trick to remember. Okay, like in the previous lesson we did. So here that is Spain, and what is the currency of Spain? Yeah, it's euro. So our trick is to remember that code is Spain and euro. How it works? Let's check. Here, look at the highlighted words. SPAIN, Spain and euro. So here South American, Pacific, African, Indo-Australian, North American, Antarctic and Eurasian. Is it easy? Clear? Good. So dear kids, now we will discuss about the plate movements. There are 3 types of plate movements. So the first one is convergent plate movement, second is divergent plate movement, and the third one is transform plate movement. I have a model here to show you. So here these are 2 tectonic plates. So let me explain the first one, convergent plate movement. See, listen. It occurs when, due to the forces of compression from two sides, two plates move towards each other and they collide. Got it? So, due to the forces of compression, two plates move towards each other and they collide. Got it? So, this is what? The first one, convergent plate movement. We'll come to the next one, that is divergent plate movement. Here also you can see two tectonic plates with me. So here I am going to explain divergent plate movement. Clear? It occurs, see, it occurs when, due to the forces of tension, two plates move away from each other. Due to the tension, two plates move away from each other. So it is known as what? Good. Divergent plate movement. So what will be the next? Transform plate movement. Let's see. So transform plate movement. It occurs when two plates horizontally slide past each other. Horizontally slide past each other. Got it? So this is what? Transform plate movement. Got it? So dear kids, our next topic is earth movements. Okay. So there are two types of movements. That is, first one is endogenic or internal forces. Further it divides into two. That is, first is sudden forces and diastrophic forces. And the second type of earth movement is exogenic or external forces. Let's learn about both. So, the forces that act inside the earth, the forces that act inside the earth are called what? Endogenic or internal forces. Clear? So, they are of two types, that is sudden and diastrophic forces. So, can you say some examples of sudden forces? Yeah, earthquakes, then good, volcanic eruptions and landslide, etc. So, the next is diastrophic. That means it will happen only very slowly. Can you? Yes, last year we learned the formation of mountain. It takes time, right? So, now we'll move to the next, exogenic or external forces. So, endogenic or internal means it is inside. So, obviously exogenic or external means outside or the surface. Let's see. The forces that work on the surface of the earth. So, that works on the surface of the earth are called exogenic or external forces. Examples are very easy. River, glacier, wind and sea waves. All these things are external forces. They act slowly and resulting erosional and depositional activities. Remember, the exogenic or external forces act slowly and result in erosional and depositional activities. Right? So now our next topic is volcano. A volcano is an opening in the earth's crust through which magma comes out onto the earth's surface. You can see the diagram of a volcano. So once the magma reaches the earth's surface, then it is called what? Yeah, it is called lava. And the passage through which lava travels is called a vent. Look at the picture. So a passage through lava comes out. Okay, so that is known as vent. So the top of a volcano has a cup shaped here. The top of a volcano has a cup shaped or a funnel shaped depression which is known as crater. This is known as crater. So on the basis of frequency of eruption, volcanoes can be divided into three types. You have already learned it in the 5th grade. So we will have a recap. So first one is active volcano. Second is dormant volcano. And the third one is extinct volcano. So let's see the first one, that is active volcano. Active volcano is the one in which continuous volcanic activity occurs and eruption can take place at any time. Okay, so eruption can take place at any time. For example, Mauna Loa in Hawaii and Stromboli in Italy are the examples of active volcanoes. And next come to dormant volcano. Dormant volcano is the one in which it has not erupted for a long time but may erupt anytime. Okay, it may erupt anytime. So for example, Mount Fujiyama in Japan and Mount Vesuvius in Italy. Okay, so these are the two examples of dormant volcanoes. And the last one, that is extinct volcano. So what is extinct volcano? Yeah, it is the one that has no record of eruption and no possibility of eruption in future. Okay, so for example, Mount Kilimanjaro and Mount Kenya in Africa, these two are the examples of extinct volcanoes. So dear kids, do you know how does a volcano look like? For example, it's just like a birthday fire candle. Do you know what is a birthday fire candle? So I have a model of volcano made out of a birthday candle. Okay, here it is. So let's watch how it works. Okay, let's see. Wow. So you can see the magma is coming out. Nice. Be careful, don't attempt this at your home. Okay. Okay. Thank you. And how was it? Really looks like a volcano, isn't it? Good. So after the volcano, we'll move to the next, that is earthquakes. So earthquakes are sudden vibrations inside the earth's crust caused by internal forces of the earth. Clear? So earthquakes are caused by the internal forces of the earth. So they may occur at the time of a volcanic eruption. So the point where the earthquake originates inside the earth is called focus. So here you can see, so the point where it originates is known as focus. Clear? So the vibrations spread out in all directions from the focus. From here it's moving everywhere. Clear? So the point on the earth's surface which is directly above the focus is called epicenter. Clear? So the point just directly above the focus is called epicenter. So earthquake tremors. Earthquake tremors are recorded by an instrument called GK question. Yeah, good. It is seismograph. So the earthquake tremors are recorded by an instrument called seismograph. The intensity of an earthquake is measured by which scale? The Richter scale. Good. The numbers on the scale ranges from 0 to 9. So it varies. Earthquakes of intensity or magnitude 7 and above can be destructive and cause heavy damage to the life and property. So now we will discuss the measures to minimize the risk of earthquakes. So here are few points written over here. You can watch. So the first point, in high-risk areas, construct earthquake-resistant buildings. So the buildings should be earthquake-resistant. And the next is, if we are in indoors, move under heavy furniture. You have to move under some heavy furnitures and stay away from windows. Okay, please don't stay near to the window during the time of an earthquake. And the last one is, mock drills should be conducted in educational institution. In order to make us aware, there should be some mock drills. Clear? So these are the three things to follow to minimize the risk at the time of earthquake. So our next topic is gradation. So you have already learned in the 6th class that degradation and aggradation, right? Okay, we will continue the same here. So gradation, the forces of nature act upon the major landforms, continuously modifying them so that the differences in the heights are reduced, right? So the Earth's surface is thus gradually leveled. Clear? So the leveling of the Earth's surface by natural process is called gradation. Please remember, what do you mean by gradation? What is gradation? Yeah, the leveling of the Earth's surface by natural process is called gradation. So both internal and external forces bring about gradation. Clear? So the external forces or the external forces such as running water, moving ice, wind and waves are collectively called the agents of gradation. Another one important topic, that is, what are the agents of gradation? What are the agents? Yeah, the external forces such as running water, moving ice, wind and waves are collectively called the agents of gradation. So gradation involves both degradation and aggradation. I have already informed. Yes. So degradation and aggradation. So the process of degradation or denudation is the wearing down of the highlands. Okay, so wearing down of the highlands is known as degradation, while the process of aggradation, what is that? It is the deposition of the broken rock fragments in low-lying area. Clear? So this is known as aggradation. So degradation can be of two types. Remember, degradation can be of two types. That is, first one is weathering and the next is erosion. Weathering and erosion. So the process of breaking down of the deposition of rocks is called weathering. So I will show you the photo or the image. So this is a big stone. You can see gradually weathering. It becomes small. Then again some other small fragments. So this is the result of weathering. Right? So the process of wearing down of rocks by the agents of gradation and transportation of the eroded materials to be deposited elsewhere and called what? Yes, erosion. Clear? So dear kids, let us now learn about the various landforms produced by the agents of gradation. So be careful this time because you are going to learn at most almost 18 to 20 new terms. Clear? So be conscious. So the first one, landforms made by rivers. Rivers are the most important agent of gradation. The valley formed by a river is narrow and shaped like the letter V. Okay, so hence it is called a V-shaped valley. Got it? So next one, when a river erodes vertically through hard rocks, okay, The valley formed is very deep and narrow. Clear? Such a valley is called a gorge. Okay, what do you mean by gorge? Once again I will say, so when a river erodes vertically through hard rocks, the valley formed. It's very deep and narrow. So such a valley is called a gorge. And since it is shaped like the letter I, it is also called I-shaped valley. I-shaped valley. Good. So next, a wider, steep wall and usually flat bottomed valley is called a canyon. Remember, canyon. A wider, steep wall and usually flat bottomed valley is called a canyon. So when a river flows down a steep valley side, there is an abrupt drop in its slopes and it plunges down from a great height, forming what? Yes, waterfall. So when a river enters the plain, what will happen? It flows slowly, forming broad sweeping curves or loops called meanders. Okay, so it is meanders. Due to continuous erosion and deposition, the meander becomes wider. Why? Just because of the continuous erosion and deposition. And the ends of the loop come closer. Eventually, the meander gets separated from the river, forming a cut-off lake which is called an oxbow lake. You can watch here. See, this is what? Oxbow lake. What is that? So eventually the meander gets separated from the river. Okay, it gets separated from the river, forming a cut-off lake. Cut-off lake which is called what? Oxbow lake. Clear? So sometimes the river overflows its banks here. Overflows its banks, flooding the surrounding area. Clear? So what will happen here? Fine silt. Called what? Fine silt? Yes. Alluvium is deposited on the banks of the river. So forming what? A fertile food plain. Okay, how long? No. So fertility of the soil. Next, the raised river banks are called what? Natural levees. Please remember, the raised river banks are called natural levees. As the river moves towards the sea, what will happen? It becomes very slow and split into several small channels. Okay, it will split into several small channels. What is that? It is called distributaries. Clear? So all the sediments carried by the river and its channels are deposited at the mouth. Okay, so the triangular shaped region near the mouth of the river with a network of distributaries is called a delta. Please be careful, what do you mean by delta? The triangular shaped region near the mouth of the river with a network of distributaries is called a delta. So the next is landforms made by glaciers. Here you can watch. This is the still model of a glacier. Okay, so glaciers are slow moving masses of snow and ice. It is a slow moving masses of snow and ice. They are also known as rivers of ice. So they are also known as rivers of ice. Here is the model of a glacier. Okay, so they are found in the polar snow fields and in the ice-capped mountains where we can find. So it can be found in polar snow fields and the ice-capped mountains. So like rivers, glaciers also break and carry away rock materials. The valley formed by a glacier has steep sides and flat bottom. It has steep sides and flat bottom. So it resembles like the letter U. Got it? So such a valley is called then what? Yes, exactly, U-shaped valley. Glaciers also carve out shallow armchair-shaped basins in the mountains called cirques or quarries. Remember these two words, cirques and quarries. When a glacier descends a valley, it melts because what? Because of the warmer climate. So its load consisting of clay, sand, gravel and boulders cannot be carried any longer and is eventually dropped. Okay, so these deposits are called moraines. So what do you mean by moraines? The deposits carried by glaciers are known as moraines. So next is the landforms made by wind. Okay, let's see. Wind action is most prominent in deserts. Clear? Wind action is most prominent in deserts as there is hardly any vegetation to check the velocity of the wind. Okay, so there is no dry vegetation, scanty vegetation to check the velocity of the wind. So when the strong winds with coarse and sand particles strike the surface of a rock, it gets eroded. Clear? So the base of the rock is eroded more than the top. The base of the rock is eroded more than the top. Eventually, the rock resembles a mushroom with what? So I will show you a model of mushroom rock. See. So eventually the rock resembles a mushroom with a narrow base and a wide top. You can watch it. A narrow base and a wide top. So such rocks are called mushroom rocks or rock pedestals. Understand? So this type of rocks are known as mushroom rocks or rock pedestals. So we have already watched the model of a mushroom rock. Okay, so now you can see the top. This area is soft and this is what known as what? Hard. So this portion is soft rock and this is hard rock. Clear? So the sand blast effect is maximum at the base, down area. So it is maximum here. So when the velocity of the wind decreases, or there is some obstacle in the path. Okay, so all the material, what will happen to all the materials? All the materials carried by the wind is deposited. The most important feature formed as a result of this deposition is what? Sand dune. Very good. It is sand dunes. So winds carry the fine sand particles away from the deserts and deposit them in humid regions. Okay. So this deposit is yellowish gray in color and forms a soil called loess. Very important. Loess. What is loess? The deposit or the sand particles carry away from the deserts and deposit them in which region? In humid region. So this deposit is yellowish gray in color and forms a soil. That soil is called loess. Clear? So our last topic is landforms made by waves. So sea waves are the most important agent of erosion. Okay, that modify coastal landforms. So in places where the coast is rocky with a steep slope, an almost vertical wall of rock is formed by the erosive action of sea waves. Clear? So in places where the coast is rocky with a steep slope, an almost vertical wall of rock is formed by the erosive action of sea waves. This is called what? A sea cliff. Clear? This is called a sea cliff. Gradually, the cliff is worn away, leaving behind a flat surface called wave cut platform. Next term, that is wave cut platform. So the cliff is worn away, leaving behind a flat surface. It is called wave cut platform. So sometimes if the rock at the base of a cliff is weak, if it is weak, what will happen? The action of waves scoops out holes. Okay, the action of waves scoops out holes which become enlarged to form caves. Another word, that is caves. Next, so gradually these caves get bigger and only the roof remains, forming arches. So only the roof is known as what? Arches. So as erosion continues, the roofs collapse. Okay, so leaving what? Only the walls, which are called stalks. Clear? So as erosion continues, the roofs collapse, leaving only the walls, which are called stalks. Stalks get further eroded to form stumps. Okay, so don't be confused with all these words. Stalks get further eroded to form stumps. The eroded materials are deposited by the waves along the coast. These deposits accumulate and form a beautiful landform, that is beach. So what is beach? The eroded materials are deposited by the waves along the coast. These deposits accumulate and form a beautiful landform, that is beach. So to remember the landforms made by the waves, we can make a road map. So here you can watch. The first one is sea cliff. Okay, so what is sea cliff? It's a vertical wall of rock by the erosive action of waves, that is sea cliff. Then next is wave cut platform. Wave cut platform, flat surface formed after sea cliff. Okay, and the next is caves, due to the action of waves which scoops out holes where the sea cliff base is weak and enlarged to form what? Caves. And the next is archer. Caves get bigger and only roof remains, so it is known as what? Archer. And the next is stalks. What do you mean by stalks? So after the roof collapse, leaving only the wall. That wall is known as stalks. And the next is stumps. Stalks further get eroded to form stumps. And the last one, that is beach. The eroded materials along the coast is known as beach. So let's conclude our chapter in the form of a mind map. So in this lesson, we have learned earth movements and major landforms. First we learned about lithospheric plates. There are major 7 lithospheric plates. We made a shortcut also, Spain and Europe. Yeah. Then we learned about plate movements. There are 3 types of plate movements: convergent plate movement, divergent plate movement, and transform plate movement. Then we learned about some earth movements like volcano and earthquakes. In volcano we learned 3 types of volcanoes are there: active, dormant, and extinct. And we learned some measures to be taken during the time of earthquakes. At the end we learned about the gradation. The gradation itself, we have 2 types: aggradation and degradation. Even the degradation is also further divided into 2, that is erosion and weathering. And at the end, the last topic was landforms made by rivers, glacier, wind and waves. So I hope you all enjoyed the video. So keep watching and we'll back with the latest one. Till then, goodbye.